up a form for that. Why should we not eat during the eclipse? You can. Shyam's asking, can I watch the eclipse with bare eyes? Please do not do so. It's not safe for your eyes to look at the sun directly. You have to use eclipse glasses or any projection method.
So there is a question on gravitational lensing during eclipse. So remember Einstein's general theory of relativity, which predicts that if there is a heavy massive object in the foreground of a star, then that object is going to bend the starlight. Now that was the theory, and in order to prove that, to give an experimental proof for that theory, Arthur Eddington in 1919 eclipse expedition planned an experiment to test the theory. So that happened to be the total solar eclipse day in 1919, and when the total solar eclipse happened, they took several images of the sky and with the background stars. And when you take the same images of the same part of the sky 6 months later, you would see that position of the stars in these two images was different. So there was a slight shift in the position of the stars, and that shift was attributed to the gravitational bending which the sun caused to the background star, or the light coming from the background stars. So this is how the lensing happens when you have a massive object in the foreground and the light is coming from a source which is in the background. It's a myth. So I'm also looking at the questions and I would respond if there is any question. So there is a question whether Earth is the only planet which can experience the solar eclipse. That's not quite correct. Remember, eclipse is happening when something is coming in between the Earth and the Sun. Now that can be true for any planet. So if there is some other object which comes in between the other planet and the Sun, that would cause the eclipse at that planet, right? So some of the moons of Jupiter as well as Saturn and maybe also of the Mars can have the similar configurations which may cause the eclipse of or solar eclipse for those planets. So it's not the phenomena which is only observed on Earth, but it could be widely observed on outer planets which are outside the orbit of Earth. Okay. Yeah, if you have any more questions, you please feel free to post it on the chat box in YouTube. While we are trying to get you feed from Bangalore, the eclipse has already started here. Sun has not sun. Our both feeds that were really very successful from IIA Leh as well as Hanley, we have seen the spectacular eclipse happening there. And right now the sun has already set. So the feed from those two places has stopped. And we will try to have it from here, from Bangalore in a short while if we are able to do that. What happens if Earth stood motionless and Sun and Moon rotate about it? No, that's a hypothetical question. Sun is the massive body, and if you look at any other objects in our universe, it's always the lighter bodies which go around the massive bodies. And by the way, nothing can stand still in the universe or in the space. They are always moving. Even the sun and our solar system is going around the galaxy. So it's also, even though we say sun is at the center of solar system, but it's not stationary. In absolute space, it is not stationary. It's still going around the Milky Way. So, some more question. The length of the solar eclipse. The world record. So as I said already, the under West circumstances, the total solar eclipse could last as long as 7 minutes, 6.5 to 7 minutes, and that's also roughly the record. Uh, there's a question that Saturn has 83 moons, and can we see 83 eclipses on the Saturn? So remember, eclipses can vary depending on what is the size of the moon and how far it is from the planet, right? So if the moon is really small and it is far away, then you might see it transiting in front of the sun, but not really causing any the shadow on the planet. So again, the occurrence of the eclipse would also depend on in what plane these planets are revolving or the moon are revolving around the planets compared to the orbit around the sun, right? And everything is not in same plane. The moon's orbit around the planets can have a tilt with respect to the orbit of the planet with respect of planet around the sun.
Yeah, so there are a few questions which are on the same topic, so I'll just club them together. While we're so we're getting a feed from the terrace of our institution in Bangalore. So please stay back. You can see now. You can see it. Thanks, Prasanna, for getting that done. In Bangalore, the eclipse started only 10 minutes ago, and the maximum coverage of the sun in Bangalore would only be around 11%. And somebody's asked why is it seen in Bangalore much after Ladakh, and that's a good question because as the moon and the earth go around the sun, the shadow of the moon travels across the earth's surface and it's traveling in the direction from north to south, right? So it started in Russia first, then Kazakhstan and Central Asia, and then it crossed Ladakh, and then it's now crossing Bangalore and South India, which is why you're seeing a time gradient in the way the eclipse is traveling. And in some of the eclipses, you would see that the direction of the shadow of the moon on the Earth's surface will be different, and therefore the order in which you would see the eclipse from various parts of the globe would also be different. There was a question about Saturn's. Did we talk about this amazing coincidence we have of this 400, the coincidence of 400?
Maybe you can tell a little bit about that.
Okay.
Yes.
So, right, people ask why we have a total solar eclipse occurring every now and then on the Earth, right? Now the question is, the moon covers the sun's disk exactly during a total solar eclipse, and you can ask why, right? It ends up being a very interesting coincidence that the moon is able to cover the sun's disk exactly now. The reason is because the sun is around 400 times as big as the moon, right? But the sun is not only 400 times bigger than the moon, it's also 400 times farther than the moon is from us, right? Because of that, the sun and the moon end up having the same angular size in the sky, which is why the moon can exactly hide the sun now. Now, this is merely a coincidence, and you can ask, this is a really strange coincidence to happen, is it natural and so on? It is, because the moon is moving away from the earth slowly, right? And therefore, the moon was much closer to us before, in which case it would have covered the sun much easier. But as the moon is moving away from the earth, in after like a billion years or so, the moon will become much smaller than the sun as seen on the sky, and then you no longer have total solar eclipses. So we can only enjoy total solar eclipses on Earth for another few 100 million years, which is therefore we're lucky that we can, right? In some sense it's a coincidence, but it's a happy coincidence basically.
Right.
There's another question saying, can the Earth block sunlight and cause the eclipse on Mars? In principle, maybe, but then the Earth's size is so small compared to the Sun's disk from Mars, like Banyal just said, that you would not be able to see it visually that easily. But then Ravindra Banyal here is also an expert on what we call extrasolar planets, right? Which are planets which we have discovered now to revolve around distant stars, nearby stars. And when you say eclipses, there is a very interesting and important connection between eclipses and discovering planets around other stars. So maybe you want to say something about that?
Yes. So as you see, we are watching the eclipse when moon is coming between the sun and the earth. Now, when we extend this idea to the stars outside our solar system, and of course, all those stars have planets around them, and now we know for sure that each star on an average has one or more than one planet. Now, when as an observer, when we look at these, and now we have instruments, photometers, which are sensitive enough to record that reduction in the intensity. And this is how one of the method to detect exoplanet works, the transit method. Transit method is nothing but the eclipse caused by the planets around the other stars, which then is the reduction in intensity is recorded by the instrument that are on Earth or space-based instruments, and that's how we usually confirm the or validate the presence of planet around other stars. There are other methods also to detect planet around other stars, but the transit method has been the most successful methods, where almost more than 70% of the total planet as of today are detected by transit method. Remember, today the confirmed discoveries are close to 5,200, and more than 6,000, 3,500 are detected by transit methods. And
Thank you, thank you. Now, Banyal has been sitting here with us since 4 o'clock, explaining the eclipse to all of us. But I think it's time he went upstairs to see the eclipse for himself. So I'm going to relieve Banyal now. Quickly run out, see the eclipse yourself, have fun, come back.
yes,
In the meantime, I'm going to ask Ramya and Aratrika to join us. A couple of questions which I think you would like to answer. One is that if you compare the age of the sun to that of the human age, what is the current age of the sun and how long does it take to become a white giant? I mean, I think they mean red giant, right? So basically, the sun's evolution. How old is the sun? What will happen to it? Piali, Ramya, anybody wants to take that question?
So yeah, I will answer part of this question. So just like there is birth and death of human beings, the stars also are born and they die and fade off. But the time scale is quite large. We are talking about few billions of years time scale over here. So now the current age of the sun is about 4 billion years. It's already 4 billion years old, and it is what we call is in the main sequence stage. So what do we understand by main sequence? This means that the core at the core of the sun, there is hydrogen fusion reaction going on, which means hydrogen is fusing to form helium. So that is the reaction which is currently happening, and that is the main sequence phase where the sun is going to spend most of its lifetime in the main sequence. So then once the core is completely converted into helium from hydrogen, so the sun will move on to slowly become the red giant, where it will expand, and this will take another few billions of years. And when once the sun attains the red giant phase, I think that is when it will also engulf Earth and other planets in the solar system. After this stage, in a few billion years, we will end up, or the sun will end up as a white dwarf. It will shrink in size, and yeah, the fusion reactions of the core will kindly cease. So that's the phase when compared to human life, which is only few 80 to 100 years old on an average. the sun will live on for about 8 to 10 billion years.
Ramya, you're muted. Okay. Thanks, Ramya. Piali, would you like to add something to that?
Yeah, I think Ramya has pretty much said everything. So I think the sun is basically in its middle age now. So maybe if the human lifespan is of the order of 80 years, the sun is probably 45 to 50 years old right now, which is what she said. So the sun will continue to shine this way for another 4 billion years before the catastrophic strikes. It becomes a red giant, and then the solar mass is not sufficient enough to form a neutron star or a black hole. So the end stage of the sun's life would be spent as a white dwarf, basically. So the sun is not going to end up as a supernova, but something much less spectacular than that. And after that nova is formed, the outer layers of the sun are shed, the sun will end up as a small white dwarf whose size is actually going to be much, much smaller than that of the Earth. So the Earth's size is around 12,000 kilometers. So the size of a white dwarf comparatively would be around 200 kilometers. So that is how the sun is going to end its life. But before it does, as Ramya pointed out, the sun is going to bulge up so much that sun is going to be similar to the orbit of the Mars. And afterwards it will shed its outer layers and end up as a very small white dwarf. So that is what I wanted to add.
Thank you.
Thank you, Niraj.
Thanks, Piali. Yeah. There's a question. Does eclipse have any effect on satellite communication? It's a good question. Not really, because the shadow of the moon is falling on the Earth, right? If the shadow of the moon was falling on the satellite, then of course its solar panels would not be able to generate energy for that time. So that would be the only effect. But there's another very interesting effect on the Earth because solar eclipses in our modern. So many countries, a large fraction of their energy comes from solar panels. And if a solar eclipse happens in the middle of the day, for example, like it happened a couple of years ago, there'll be a sudden decrease of energy flowing into the national grid from the solar panels, and therefore they have to take special care to make sure that that doesn't have any adverse effect, doesn't trip the entire grid or something, right? So they have to slowly reduce the power from the solar grid into the national grid and then raise it again after the eclipse. So it's kind of an interesting effect solar eclipse have on our modern life. In Venus have an eclipse on Earth. So we answered that earlier, but let's handle that again. Aratrika, would you like to handle that?
Yeah, of course. So the thing is that both Venus and Mercury, those are pretty small planets, and both are quite far away from us as compared to the Moon and Earth's relative size and distance. So the thing is, they do form shadows on Earth, but they are almost negligible. They cannot really be observed by us. So those are mostly called transits, not eclipses in that sense. Yeah, I hope that's enough.
Yeah, thanks a lot, Aratrika. Yeah. So we do have Mercury and Venus transits. There won't be any of them soon. We had a couple of Venus transits last decade, and also a couple of Mercury transits. Nowadays, we observe transits because they look beautiful. Like, the eclipse looks beautiful, so does the transit, of course. But the transits have a historical importance. It was by measuring the time of the Venus transit from different parts of the Earth. that we first knew how to calculate the actual distance between objects in the solar system. So till then, we only knew the relative distances. We knew that, for example, if the distance between Earth and the Sun was 1, then Earth and Venus is so and so, Jupiter and Sun is so and so on. Everything was relative to a given distance. But to calculate the absolute distance between objects in the solar system, Venus transit was what was used in the 1800s to calculate them accurately. Now, of course, there are much more accurate ways of doing so. What is the effect of radiation skimming across the moon falling on the Earth? Not really. The radiation skimming across the moon falling on Earth is almost negligible. It would be because of gravitational lensing, and that's extremely small because the moon's mass is very small. Anyway, it would still be far less than without an eclipse, right? So there is no effect, there's no harmful effect of the eclipse on us. There's no extra radiation coming from the solar eclipse which will affect us. You can eat, you can drink, you can go out, you can do whatever you want to, and so on. It's an interesting question about the impact of the eclipse on the waves in the ocean. That's an interesting question. Of course, we know that waves are, I suppose you mean tides, so I'm going to assume you mean tides, right? Uh, Tides in our ocean are caused by the moon's gravity as well as sun's gravity, and we know that the moon plays a much more significant role in affecting the tides in our oceans compared to the sun. And of roughly the same direction, the tides add up and you get stronger tides. And that is true for every new moon, for example, right? During full moon, you get less tides because they're in opposite directions. So the tides during a new moon and during an actual solar eclipse aren't that different because the moon is almost the same direction as the sun within 2 degrees or so. So there will not be much noticeable effect on tides because of the eclipse over and above what happens during a new moon anyway. Yeah, so as you can see, the eclipse is ongoing in Bangalore, and that is because we're far south, and the shadow of the moon is moving southwards from Russia down to South India, and therefore, as time went by, we started with the eclipse in Russia, then Kazakhstan, Central Asia, Ladakh, Central India, and now and sun is set in Ladakh now, and now we are seeing the eclipse from Bangalore. In fact, we're seeing it from the terrace. There are Prasanna and other colleagues of his are upstairs sending us the live stream of the eclipse, which is being relayed from by Swastik, who's here. I request Swastik to come here and say hello because he's been doing a lot of work, and I think people should see him and say hello. That's Swastik is a student here. He's doing his PhD in IIA, and that's it. And so he and Amit have been behind the computer since 4 o'clock, and it's because of them we've been getting the live stream from across the world. So thanks. Swastik.
Yeah, hi everyone, and here I'm Nitin. I'm still alive.
Yes. So as you can see, the sun sets in Bangalore at 5:55, but it will set probably a few minutes before that here because we have some trees and buildings in the horizon. It's 5:40 now, so we will continue this till sunset in Bangalore, and then we'll stop this transmission. We still have quite a few of people with us now. Thanks for staying so long. I will and Randeep Singh says hello, Swastik. I don't know if you know him.
Okay. Yeah, hi from my end.
Yeah. So somebody's asked whether shadow of the moon falling on the surface of the sun is called a solar eclipse. No. The light falling on the moon is because of the sun, and therefore the shadow of the moon will always be behind the moon as seen from the sun, and therefore it cannot fall on the sun. It's like saying shadow of me because the sun can fall on the sun, it can only fall below me, right? So that's how it is. Yeah. So there are some questions about how come ancient Indians were able to predict eclipses without telescopes and so on. That's a very good question. So astronomers from across the world in many cultures were able to predict eclipse very accurately much before telescopes were invented. In the sky. So Indian astronomers starting from Aryabhatta up to the Kerala School of Mathematics, and even later, if you look at Patani Samatha Chandrasekhara in Orissa, have had perfected or had continuously updated the methods of calculating the paths of the moon and the sun in the sky, and therefore the eclipses for many centuries. Similarly, it was also done, for example, in Europe, in China, in Mesopotamia, long back, in Egypt, and so on and so forth, in Greeks and all that. So the model they used was that they would model the across many centuries, across various cultures, including India, so that it agreed better and better with the observations. But of course, once we realized globally that it was the sun that is the center of the solar system and not the earth, then we threw away the epicyclic model and came to the heliocentric model, where of course the calculations became much, much easier. And now, because we can use dynamical equations from Newton's time, we can add in the effect of very small perturbations. For example, the effect of Jupiter on Earth's orbit, or effect of Saturn on Earth's orbit, and so on. And therefore, we can refine our predictions even more and predict eclipses much more accurately than we could before. But there's one very interesting application of ancient Indian eclipse observations, which is pioneered in Bangalore actually by Dr. B.S. Shailaja, who is the director of the Jawaharlal Nehru Planetarium in Bangalore, and her student Geeta Kaidala. They looked at stone inscriptions across Karnataka and Andhra, dating 2000 years ago, so last 1000 years, in old Kannada. And some of them would be recording, gifts by the kings and so on during an eclipse, right? And they would then mention, okay, this village, this eclipse was seen at this time, and this is when the king gave so much money to the temple, and so on. And this kind of thing is found in other parts of the world as well. So what people do, including Dr. Shailaja and a student in Bangalore, is that we know when the eclipse should have occurred and where it should have occurred, let's say 800 years ago. You compare that with the records, and then you can check if there's any error. And any error can then be possibly attributed to delta T studies, and it's very important, right? So if you have eclipse records in stones or parchment or whatever dating back 1000 years, 1500 years, you can use that to have constraints on how much the moon's orbit has changed by very little bit. And this is something which is being done in India as well, increasingly, along with other records in other parts of the world. Are there going to be an impact of climate change on the eclipse? No, not really. If except that our atmosphere might get very, very hazy and murky, and we will not be see anything. But that's no effect of climate change. I'm just holding the fort till people come back from upstairs after they see the eclipse. So I just keep answering questions till sunset. Are there any electric and magnetic field effects of the eclipse on Earth? No, no, there's not really. Not on the Earth's surface. Impact of eclipse on astrophysics in India. Oh, there's plenty, there's plenty. So eclipses are, as you're seeing, beautiful events, right? Like absolutely marvelous events, and there's something which excites everybody, right? So a lot of people I know got interested in science or astronomy because they saw an eclipse safely at some point, right? But astrophysics development in India itself was influenced very, very deeply by eclipses. The total solar eclipse on 18th August 1868 passed through Andhra Pradesh. Okay, and in Machlipatam, and then this just when spectroscopy had been invented, right? So Pierre Janssen had set up a camp in Guntur in Andhra, and Norman Pogson, who was the director of the Madras Observatory, had set up a camp in Machlipatam in Andhra to see the eclipse, and in particular look at the spectrum of the corona and the chromosphere at totality. And he ended up discovering the element helium during his eclipse in India. So that's a very important, Indian connection to solar eclipses, right? Do eclipses help the planet in any way or useful? No, they're not useful, but they're beautiful. And I think a lot of things can be beautiful and not really useful, and that's part of why things are beautiful, right? Yeah. So you can. So somebody asked about Varahamira and so on. So Aryabhatta had actually mentioned very clearly that eclipses are caused due to the shadows of the sun and of the earth and the moon falling on each other. Okay, and he told you how to predict them. Varahamira and Bhaskara did not agree with him a little bit. Varahamira and Bhaskara invoked Rahu and Ketu. Aryabhatta did not. Much later, Lalacharya, who was another famous Indian astronomer, said the same thing. He said, "Look, eclipses are not caused because of demons and so on. That is a story. but eclipses are caused only because of shadows of the Earth and Moon falling on each other. And a lot of people in that age made fun of Lalla. Lalla was a very famous astronomer who lived, I think, 800 years ago in Gujarat, in present-day Gujarat. And people made fun of him, but he said, no, no, I know, I can observe eclipses, I can understand how they cause. And he insisted that the stories you have about eclipses are stories, but we understand the science behind them, and it is because of shadows, and therefore they're perfectly harmless, right? So no, so I would rather follow Aryabhatta and Lalla personally. So Ravindra Panyal is back here. Do you want to tell us how the eclipse was upstairs? You can turn your video on.
Okay.
And tell us what you saw.
Yeah, so I had just gone out and saw the last part of the eclipse from Bangalore, and it was spectacular. We had like several students there and some visitors as well. So I would also urge people who are living in the southern state, and if they have a clear sky, they could probably step out and have the last glimpses of this eclipse, because the next one is going to happen maybe 2 years down the line. So this would be the last and the right opportunity to take the final glimpses of this year's eclipse that is visible from India. Right now, only from southern state. I'm sure most of the northern state, the sun has probably already set.
Yeah, and it's setting in Bangalore as well.
It's
I think it's set in Bangalore. The sun looked weird because part of it is covered by the buildings and the moon.
Yes.
There you can see the sun being swallowed up by some apartment complex, while it's also being swallowed up by the moon from the other side.
Yeah. Can you imagine now anything?
So we'll wait till the sun sets in Bangalore, and then we'll stop this live feed. This is the last view of the eclipse sun from Bangalore currently. It's already set in North India.
So there's a question.
And in Bangalore, the maximum is around 11%. So 11% of the sun's disk is covered by the moon. There we see the last remnants of the sun. And I also want to introduce you to Amit, who's been behind the computer along with Swastik, bringing us the live stream from 3 different places in India and 2 abroad. So that's Amit. Say hello.
Hey guys, nice to be here. And
now we see that the sun is set. Yeah. If you're at the apartment complex there, you will still see the sun eclipse, but then they're hiding it from us. So, last words, Panyal?
Yeah, so I just want to say that these solar eclipses, they are natural phenomena, and they are not harmful, neither they are anyway auspicious. They are beautiful, as Neeraj has said, and we should not deprive ourselves from these wonderful spectacles that happens once in a while in the cosmos. So please go out and enjoy and encourage others also to take part in these things.
Well, the sky is beautiful in the daytime and at night time. So, go look up. Contrary to what Netflix documentary's name was. At night, go look at the sky. If you're in a big city, of course, you can't see many stars. But if you're in a small town, then you have the entire sky for you. The beautiful Milky Way, the planets which move every day. Go to the nearest planetarium or science center. Find out more about astronomy. They will have telescopes there to show you stuff at night time. Go online, look up the lovely videos explaining basic astronomy on YouTube. There'll be amateur astronomy clubs in almost every town and city in India. So find out the nearest amateur astronomy club, join them. And before we say bye, Piyali and Aratrika, would you like to say anything?
Yeah, so I could also catch a glimpse of the eclipse while on this NH48. But I could not watch it at the maximum thing because it is already now below the horizon. But while it lasted, it was really wonderful. And the sky was totally clear here.
Yeah. Thanks, Piyali. Thanks for joining us from NH44. Aratrika, any last words?
Yeah, I would like to see the results of the eclipse hitting hashtag that we floated. Yeah, after this, check that out.
Thank you. Thanks, everybody. So I would also like to thank a whole bunch of IA staff who have been with us preparing for this live stream for many weeks now, from Leh and Hanle, Ladakh to Kodaikanal to Bangalore to to everywhere, and as well as all our students who've been preparing these wonderful videos about eclipses in 12 different Indian languages, created posters, and helped us have this wonderful awareness campaign, which has brought all of you here for the last 2.5 hours. So thanks again, everybody, for staying with us on YouTube. And we'll meet you at the next celestial event. So meanwhile, look up at the skies, look at the stars, and have fun with the sun. Goodbye.
हेलो हेलो हाँ जी, मुझे ना डेंगू हो गया, मैं बेड रेस्ट पे हूँ, फुल रिफंड चाहिए।